Hello and welcome to 34th lecture of course on data-enabled tribological engineering from experiments to predictive model. Topic of this lecture is data management and ethics in data-enabled engineering. In my view, this topic is very important. Reason being, today's technology-driven world, data holds significant importance, particularly in engineering domain. Data can be extracted from published literature, archives, simulation, and experiments. To integrate those wide variety of data, effective data management is required to ensure data accuracy, accessibility, reliability, thereby improving the decision making. Data-enabled engineering presents numerous opportunities, but also poses a number of challenges. Particularly, we want to ensure high quality training data for effective model performance. Therefore, special attention must be given to data preparation, including techniques like data discovery, cleaning, labeling, and storing to ensure retrieval and utilization of data for training, testing, and reinforcement learning. In the present lecture, we will examine the critical role of ethics and data management. In connecting data management with tribology, it's essential to engage in activities such as monitoring material samples and the test cases, strategically planning and executing tests, thoroughly analyzing the test data, and securely storing results for the future references. This practice helps minimizing the risk of errors, inaccuracy, and inconsistency. In essence, prioritizing data management and ethical consideration is paramount in harnessing the full potential of data-enabled engineering. Such guidelines not only drive innovation but also ensure responsible and sustainable use of data for the betterment of the society. So let me start with what we have already covered in a data-enabled engineering. We introduced this topic in a lecture 20, and of course acronym was given a DEE. And then we say this data enabled engineering will be covered in a lecture 20 to 22 and 33 to 36. Of course, special attention was given to data enabled engineering in a coding selection lecture 14 and design of experiment in lecture 19. So what is the importance? We say data enabled engineering is a method of improving and supporting engineering processes using the data. However, the focus was given how to integrate data into engineering workflow. It's very important. However, it is also written the data-driven engineering, which is a slightly different than the data-enabled engineering, which was covered also in the lecture 23 to 32. It really requires extensive use of data, but to provide the decision making also. While in data-enabled engineering, decision has to be made by the human being. They take a support of the data. So data driven in the engineering is involves extracting valuable insight from data through application of data centric techniques. So this is very important when we are going for data driven or data centric techniques such as a machine learning and advanced analytics. We need to be very careful about the data, and it's very important. That's why we are going to cover in this lecture. So what we say, data enabled engineering, which was introduced in lecture 20th onward, is basically interdisciplinary field that integrates conventional engineering principles. So we are not discarding any conventional engineering uh, phenomena or principles, but we are trying to get a support of the data science method to enhance overall efficiency of designing, developing, and operating intricate systems and processes. We say data enabled engineering effectively utilizes extensive archived data. We have so many data available in the literature, and then we also need to top up our own data using the sensor technologies to enhance the decision making, increase efficiency, and stimulate innovations. So what is the relation between the machine learning, data enabled engineering, and data driven engineering has been highlighted in this slide. What is the easy way to drive? I will go from bottom up. It's a data driven engineering. Here we try to do some sort of design validation. What's the meaning of that? We say in this case machine learning assists validating engineering designs by analyzing the experimental data. That means already we have designed something and we are getting data and we are trying to validate whatever we have done, is it correct or not. So ML algorithms can compare simulated results which we get from analysis or is a theoretical calculation, and compare it with the observed data to assess the accuracy and reliability of engineering models. Second thing comes, because we are doing in situ data preparation, in situ data retrieval, there we can do a process optimization also. What is been written here, ML technique can optimize engineering processes. How? By analyzing data, uncovering inefficiency and bottlenecks. So they, using the data driven engineering, we are able to find out what are the inefficiency, what are the bottlenecks, and what are the areas of improvement, and that everything is being done in situ when it is in a process or it is in an operation. Coming to the design support, many times we can do for the automation, and we say ML model provides a decision support by analyzing data and recommending optimal course of action, which is very much is required for the automation purpose. So ML algorithm can analyze operational data to identify opportunities for process optimization. So we are trying to figure out the faults that should be rectified immediately, so that overall process is improved, or it's not going to further deterioration, and we are able to take an appropriate action. Coming to the data enabled engineering, we say one of the major advantages of predictive maintenance. Of course, very similar to the data driven engineering, because we require in situ data. However, before that, we really required what is a really fault and what is the impact of the fault and how it will be analyzed, and what kind of judgment can be made. That will come from a data enabled engineering. Data driven engineering will require some rules and regulation which has been derived for the data enabled engineering. So we say ML algorithms detect the patterns of indicative potential failures, and here failure have already been signature identified and given some pattern there, and we are trying to analyze the data and which pattern is really matching the failures. So predictive maintenance strategies can be decided based on that patterns. ML algorithm can predict when maintenance is likely to be needed. Earlier it was used for the replacement kind of thing, and after 5 years you replace a component. However, in this case we are trying in situ data, and then we are trying to predict the what is the fault and where the failure possibilities of failure, and then we are giving some sort of strategy for the maintenance. So that is very important in this case. This is very important from a design point of view, because we are trying to retrieve data from a literature and in a much more meaningful manner. It's not that we are assigning or we are looking only at the one handbook. We may look at the many handbooks, many research reports, and try to analyze the data by removing the unusual, or we say the useless data as such. So that is where the we say the data management is very much required. So ML techniques apply to the optimized engineering design process by analyzing the performance data. In this, like a tribology, we have performance data like a friction, where similarly in other design criteria we will have some sort of failure criteria that can be also analyzed to identify design parameters that lead optimal outcomes. We do also the sensitivity analysis. We also figure out which parameter really will impact and which parameter really required to be closely controlled. All those comes with the data enabled engineering. And finally we say that data analysis and modeling, we do a lot of assumption, or we model things, or model system using the number of assumption, how assumption will be justified, and then when we have a data and then we are able to capture the data, we can improve that. However, because we have to analyze a large volume of the data generated during the engineering processes and system and sensors, we really require to integrate those data so that those data can be utilized appropriately and can be utilized for the modeling purpose. So once a model is ready, that can go and maybe can utilize for the data driven engineering, and maybe rectified subsequent or improved subsequently. So this is where the machine learning comes in a very big way. Earlier machine learning, without a machine learning, we were able to do data enabled engineering, but with a lesser number of data. Now we have a number of algorithms which are we are able to analyze a large data. We are able to integrate in a systematic manner, and we are able to retrieve those data also whenever we are requiring. Of course, this is a similar kind of thing which we were earlier doing for the expert system. However, in expert system, all the rules and regulations were fixed. We were not changing it. While in this case, data driven engineering, when we are adding, we are changing those rules and regulation optimally and wherever it is required. It's not that few data we get and immediately change it. We need to analyze those data, ensure that whatever we are getting, they are accurate, precise, and then we really require to change the rules. So there is a somewhat different between expert system and this approach, and I will say that the data enabled engineering is a bigger domain. It incorporates a data driven engineering also to some extent, and then it utilizes in situ data to improve the system. How? We will be discussing in this lecture. So first thing comes data preparation, because we are giving a lot of importance to the data. We say data and preparation is required. What's the meaning of that? The transforming new raw data from a sources into the format which is suitable for analysis. Again, when you go through the number of handbooks, number of research publication, everywhere the data has been given in different formats. So we need to have a suitable format which is really required for our analysis purpose. So we can say the data preparation encompasses the three primary modules. One is the data discovery, that is identifying the right sources. Then we need to, if we identify these data are matching to some extent in format, or we are able to make it in our format, then the data cleaning is really required, because many times the data will be missing, may not be there. And finally comes a data labeling, because we can have 5 variables, 10 variables, 15 variables. Every engineering system will have a different kind of variables. So we really require data labeling from that angle. So let me explain. Data discovery, say we say that sourcing training data from external repositories such as a web. However, in these days I say that don't utilize a web, because many times we are getting wrong data on the web. Handbooks to some extent can be relied. Research article to some extent can be relied. Of course, in these days all the research article they need to upload all the data, so to some extent can be analyzed. But again, we do not go ahead with the blind faith on those data. We need to analyze, understand, and if there is some sort of good inference from those data, then only we should utilize. And what is data cleaning? We say the focus on rectifying the dirty data. Dirty is a terminology been utilized. We say dirty means which is including and then the missing values or outliers. Somewhere we have duplicated value or inconsistency. There's no pattern at all. You have a 10,000 data and there's no pattern at all. So what will you do with those on the data? Maybe you need to have some sort of filters, some sort of data cleaning method, or maybe finally you can reject or accept 50%, 60% those data. But again, we need to be very careful. We should not be biased, because when once we get a bias, then the science will be missing. We want to really find out the science behind those data. It should not happen that I thought something in some hypothesis, and then out of 10,000 I pick up the 5,000 data, 3,000 data. That will be wrong. Inconsistency need to be kind of the blind, where we have emphasized overall hypothesis, we have made some sort of model, and then we are testing against that. We are not uh, selecting few particular data. That will not be correct. That's what we many times say, cherry picking should not be done. That is against ethics. We will be discussing that thing also in this present lecture. We in lecture 20 we also say that this data enabled engineering can be utilized in a big way, particularly for the health monitoring of the system, which is very much required, because we don't want any system should fail. A system can be gear, can be cam follower, can be bearings. So there we should not any system should not fail. We should able to identify the faults, and before any failure, before any major casualty, we should be able to replace it, or we do some sort of rectification. So when we say the identification of potential issues by the real time monitoring, and particularly we use NDT techniques also. That means all the sensors which we are utilizing, we are getting data, we are doing the analysis of those data, and what we use a word the real time monitoring or in situ monitoring. That's very important. Based on that, we can predict some sort of strategies for the predictive maintenance. We say that we need to anticipate what will be the equipment failures, and the anticipation is well in advance, the maintenance strategy can be really done properly. So that's why we say it promotes proactive maintenance, reduce the downtime. and causes a lesser and lesser economic losses to us. Finally, this kind of data enabled engineering should be used in a big way to design optimization. Of course, we already shown data driven engineering will be used for the process optimization, while in this case we are seeing the design optimization. And then if you are before engaging or before applying the process, if you are doing optimization because of the earlier knowledge or the knowledge which we have gained from some processes, or more monitoring the some processes, that then we can also utilize a process optimization. Well, in this case we are seeing the design optimization. It incorporates established correlation, and in the design process, M is to enhance the performance, efficiency, and main thing is the cost effectiveness. As we are moving with the newer and newer technologies, more and more technologies are coming, and more better and better sensor, the cost effectiveness comes, so that we should be able to imply or apply those kind of new technologies. When to change the technology, how to change the technology, naturally data enabled engineering helps in a big way. So not necessary that whatever we're using the equipment so 30-year-old, now we require delta variation, some sort of variation in that, and then now we are able to improve the performance, efficiency, and reduce the cost. Better we should do that. This we were talking about the data and the database, and then we covered this also in the lecture 20th. We say that this is the one of the way of the data discovery. A reference has been given from where we have picked up, and we assume that almost all the countries have given some attention to make some database. And of course, what are the major issues in this database? Even though there are so many database available, so there are some sort of restriction. What we say, the tribology has a major issue, because that's what has been given in this case. Challenges in tribology, we say the tribological experimental results are mostly influenced by several factors, and whatever the database we have, they are incorporating some factor, not all the factor. So what are the factors? A load is a factor, velocity is a vector, relative velocity basically, operating temperature, type of the motion with a rotary, reciprocating, linear, contact geometry, whether it is a straight or convex or concave. And one of the major issue comes, which is not being recorded appropriately in all the databases, surrounding medium. Often the medium has not been highlighted. So reason being, because of that we are getting different kind of results. That's why we say the database must include the detailed information about the test parameters. What are those? How the materials are treated. Even then the few material hardness may be slightly different, even the composition is same, because the way they are treated, that is also going to affect. Even their properties also will change. Heat capacity may change, density may change, electrical resistance may change. Not only this, in some database we are able to find only the varies. In some database we are able to find only a coefficient of friction, but that may not be correct. We need to really give all the things. What is the coefficient of friction? What is the wear rate? And what are the test parameter? What are the surrounding medium? What is the contact geometry? Because everything really affects overall performance. So that's why we say the tribology is slightly more complex, and making database itself is a big challenge. So in this case, so whatever the, if somebody is able to make a very good database, it will be helpful to the users. Reason being, they will be getting significant benefit from assessing the comprehensive information. Of course, as I mentioning, that comprehensive information is missing presently. And then if in future some researchers, some labs or some countries, they are able to make a centralized tribological data source, naturally it will be very good to disseminate the research knowledge, so that people can use for the practical purpose. What is as I mentioned, there is a challenge in tribological database, and this was highlighted in lecture 17 as well as a lecture 33. And then we say ASTM follows all the standards, but even when they do in-house and across a lab test, they are able to find out the coefficient of variance very high, 29.3%, 40.2%, and so these are the variations are very high. Question comes, if somebody is giving a results of 5% variation, 6% variation, or reduction in wear rate by 20%, that itself is accounted in a big way. But when our results itself vary significantly, then how do we believe it? So ideally, we should incorporate all uncertainty quantification, and that can be only accounted when the database contain all the and the required properties as well as a medium load, velocity, and operating temperature condition, which is slightly tedious. We are believing that in future those things will also be available. Our present lecture, we are just focusing only on the data and data management. So I'm just trying to give one example, or one I'm trying to cite one paper which was published in Where in 2019. The title of the topic is an analysis of the quality of experimental design and reliability of results in a tribological research. What was the aim of the paper? To find out what is happening when the people are trying to solve a high profile projects. So what they conclude is several high profile projects have raised the doubts about the repeatability. That means even in some lab, the results are repeated, we are not getting, or in across the other lab, we are also not getting. And that creates a lot of confusion about the validity of the scientific research. Of course, it started from the two areas what they are mentioning, psychology and medicine. They say that less than 50% of the published research finding in the psychology and medicine field are true or replicable. That means lesser than 50% published data only can be relied. And then they are also mentioning they have not thought about it. It is even without a breach of ethics. That means wherever the data or ethical data, people are not manipulating data, still in that situation, lesser than 50% results are only can be relied, because they are not able to get a replication of those results. When we are not able to get a similar results, or they are not able to compare those results, then naturally there will be issue to develop some sort of theory and blindly believe in that. That's why we are saying again and again, we learn from a literature. Finally, we need to come up to the data driven approach, where we are taking the data from experiments, we are modifying whatever the models we have made, and that only will lead to the future. And we say that the digital twin which we have been thinking, or cyber physical system, which will be also covered in lecture 35 and 36, that we really require. Now, how they did analysis particularly for tribology, they say examination of data related to tribology, they use four criteria: whether those data were randomized, whether the readings were taken in a blind mode, whether they had a complete control or not, and finally repeated test. So they found that only 2.2% of whatever the experimental studies they examined, 290 experimental studies, they utilize a blinding. What is the meaning of blinding? The person who's doing experiment, he may not be know which sample he's going to test. If we already know which sample we are going to test, there will be some sort of bias, and that is where the problem comes. Either we do everything automatically, that means we give samples, maybe 10 15 samples, and automatically those things have been done, then there's no problem. Otherwise we need to be not informed about the sample and we should the test. Second thing is the randomization, and then the randomization, we say they incorporate only 3.2%. Why do we do a random test? Reason being the history dependence should not come. Often people start with a 0% of some particle, then 0.2%, then 0.4%, then 0.6%, then 0.8%. So some sort of history dependence comes on that results. However, when we are giving the random numbers to that, it can be picked up anytime. 0.2% can be picked up 0.8%, then 0.6%, then 0%. So that randomization is very much required when we want this reading to be more reliable. Also, they found that only 30% experiments people have done the test for the 3 times or more than 3 times, which is a minimum. We say the minimum 3 readings are really required. One more thing which they observed, 80% of those whatever the repeated results, they use a single batch of their test material. What is the meaning of that? That when we are taking sample, like I want to try MOS2, if I'm taking from one source only in one batch, quite possible I may get a biased results. So it will be preferable to either buy from a 2 to 3 vendors or maybe the different batches. Then the results will be much more reliable. That's what has been mentioned in this case. Finally, they mentioned that only 4.4% of the studies are related to statistical tests. We know that most of the tribological tests are related to statistical performance. That means the friction continuous will be vary, wear continuous will be varying. So we really require a statistical testing to be done on those outputs. However, if we are doing only a deterministic point of view, then results may not be relied. So finally, they say that due to low occurrence of repeated tests, the statistical analysis realistic estimate of the false positive are unattainable. We cannot rely on the test. Again, question comes, if we are trying to dig out from a literature, how do we go ahead? So we need to really look at these points, whether they have done repeated test, whether they have applied line criteria or randomization criteria or statistical evaluation was done appropriately. If it has not been done, naturally there will be a little lesser hope of the validity of those data. So then whenever we are doing our own research, we need to focus on these parameters so the results are really useful to the society. Otherwise, what will be happen, we will be getting some data for our own purpose, but it will not be going to the society. And particularly when the people are taking a project from a government or government funded project, actually they need to do things or research in a manner so that it is useful for the wide society. It is not for their own purpose. We also covered in the lecture 20 the maintenance, and what we say, because data which are available in literature may not be 100% correct, or on previous slide we showed only 4.4% data can be relied. So we given little more emphasis on in situ data collection, and we say in situ data collection is crucial for every physical system to record their natural degradation. We are also believing that every system will degrade over the time to ensure safety efficacy of the industrial sector, thereby effectively managing the risk. So this is what we don't want, any fatal casualty should happen. If maintenance is really required, in situ data monitoring is very much essential, and that was also covered in lecture 20. We also mentioned that this corrective or breakdown maintenance, which was earlier done, now may not be recommended. And then we are giving a lot of emphasis on predictive or condition based maintenance. Even the preventive maintenance, which is done based on the time, that after 5 years you need to replace, after 10 years you need to replace, after 15 years you need to change a vehicle, that is a preventive maintenance that also should be discarded. We should more focus only on the predictive maintenance, and for that purpose you really require continuous data, or need to capture the data, analyze the data. Quite possible we may and the get much higher service life of the component compared to what we have been doing in a preventive maintenance. This is very much required from a sustainability point of view, because we don't want to utilize more and more raw material, more and more energy, and material utilization or energy utilization both are parameters related to sustainability, which is a future. If we are able to do anything to make a sustainable future, sustainable environment, that will always be appreciated. So that's why we get a data and continuously monitor it. And then we also know that now the sensor cost is coming down significantly. Data acquisition system cost is also much lesser. So those things can be implemented. Earlier those were new technologies and people were not able to afford, but now this everything is affordable and being incorporated in various machines. We also covered something on lecture 22. We say employ optimization model for real-time monitoring and extracting the relevant features from data obtained from embedded sensors. So we can go ahead with the optimization, maybe is a process optimization, and it helps to enable the predictive maintenance by identifying bottlenecks and area of improvements. So this is the same thing, process optimization, which we are doing. They're trying to figure out what are the problems. To some extent, we also covered predictive maintenance in lecture 26. We say predictive maintenance, it is anticipating and preventing failures through the data. And here we have given a lot of emphasis on the data driven insights, because many times we do not have a complete knowledge of the system. And when we are examining the data which we have found from data driven engineering or data driven approaches, then we are getting better and better understanding of the tribological processes, because tribological processes are very complex processes. That's why we are given emphasis that we should shift towards the data centric approaches, so that we are, whatever the decision we are taking, it is a better informed decision, and overall we should be able to get a cost effective and efficient problems, or we say efficient problem solving methods. Now, if I see the what are the key components which we started the lecture 20th, and then why we are again and again coming back, because I mentioned that we will be again discussing the data enabled engineering lecture 33, 34, 35th, and 36 also. So here what we are saying that the main key components or maybe the key components of data enabled engineering are integration. Here the collection, analysis, and utilization of the data are important. Now data, we say we can figure out from a data book, historical records. This is also important. Many times if you are working in industry and then we have a lot of records, we can rely on those data. To some extent the data book which has been also written relevant to our industry, then it will be really important. Simulation, because we cannot do all the experiments. I can do 10 experiment, 22 experiment, 30 experiment, and figure out some sort of pattern, some sort of model, and then do a subsequent simulation on that. So those things are also important. So we say simulation and experimental method. And last one is the operational data. This is what we use a word a data driven approach. One is a data enabled engineering, we require all, but data driven engineering we require mostly operational data. This is what to improve the engineering designs, decision making, and performance of the tribo systems. So these are the very much required. Now another key component comes, we should utilize the cutting edge technologies. What are the cutting edge technologies? We should utilize a sensor technology, data acquisition systems, and then advanced computational power also must be employed, because we really require high quality and diverse data. What is the meaning of the diverse data here? We try to repeat, we are maybe having to get a similar data, we have a two sensors or three sensors also, and when we have a two three different sensor and they are converging to the same value, naturally we will have a lot of confidence on those data. If I'm getting data only from one resource and I'm not getting from other resources, or maybe I'm getting data from two different resources and they are not showing the same train or maybe the same kind of system, or they are not able to really converge to the similar kind of conclusions, then naturally we may have a problem. I will say that we need to go ahead with the improvement of data. So when we have a two to three senses for the same on the observation of same data, it may increase the cost to some extent, but of course we will be getting high quality and then more reliable data in this situation. We also covered something in lecture 27, and we say that because we are talking about the cutting edge technologies, we need to think about the image processing techniques, because we know very well exploring image processing technique is very much required, particularly to find out the surface degradation or wear debris. So this is where will be very important to diagnose a machine's condition accurately, more much better manner compared to the debris reaches to the sensor. Here suppose in this situation we are able to take a picture and analyze. We know that there are some sort of wear in grooves, but there is some sort of plastic deformation, what we have covered in lecture 27, something called a galling, which is also deteriorating or degrading the surface. It's not only the wear particle which are showing the degradation, but even the deformation, plastic deformation of the surface itself is causing some sort of a degradation. That should be at the nascent stage, it should be captured. Of course, finally it will cause a failure, but if you are able to diagnose well early in the stage, we can do a remedial action on that. So what we see, by employing advanced image processing and automated techniques, prediction can be made more accurate, thereby assisting in a better maintenance of the machines and enhancing their operational efficiencies. Creation of predictive model utilizing this kind of technique naturally will be much more accurate or highly accurate, and reliable. They give a more emphasis on cutting edge technologies, machine learning, and in situ measurement and in situ fault diagnosis. That is very much required, and I hope now we have sufficient knowledge to implement this kind of techniques. So what we see, what are the essential elements of the data enabled engineering? We say we think about the data collection, data analysis, optimization, predictive maintenance, simulation, and virtual prototype. We have not covered. It requires a separate course for that because that's very very important. And in future, it will be going to become a big tool for the designs on tribology. One more important thing comes is that continuous improvement. We design something, we are not happy with only that, and there is a continuous improvement requirement for that. So the next system should improve, even maybe delta, but it should improve compared to the existing system. And for that again we really require a data enabled engineering. And one more constraint which we have mentioned, something like interdisciplinary collaboration. Either we should get a more and more knowledge, or we go with a collaborative approach. In my view, collaborative approach will always help a lot because they are diverse minds and working together, they are giving much better innovation compared to the what we can do alone. So that's why we say the data enabled engineering involves a collaboration between engineers, data scientists, domain experts, and other stakeholders, because whatever we are trying to implement, that is discussed appropriately. Coming to the continuous improvement, we say that because we are leveraging on a data driven feedback, and this data driven feedback loops will help us to improve the system continuously. As I mentioned that this simulation and virtual prototyping we are not covering in this course because this really requires many more techniques: creating virtual prototypes, simulating the real world scenario and to the test and design. And of course we have many other techniques in this to really come up with a complete simulation and virtual prototyping. And finally it can go to the data driven approach also. Predictive maintenance we already covered. Optimization and decision making, yeah, to improve the reliability, yes, we are done here. In this case we have been utilizing the sensors, but sometimes we don't have sensor wires and all. If it is done by internet of the things together, then it will be really important for us. Even getting data from historical records is also important, particularly for the laboratories, or particularly from the industries, because they have over the years number of data. However, from academic point of view, because we work only for 3 to 5 years on one project, we may not have those many data. But industry, they work years and years. Research lab also works on years and years, so they will have records, and those records may be relied also. So what we can now come to the topic of this lecture. We say data management. We discuss something about data collection, data storage, data quality assurance. We have not discussed. We will be discussing data governance. That's another important aspect. Data integration to some extent, yes. And one more point comes to data lifecycle management. So these are the important aspects of the data management. We say the overall data management is a process of collecting, storing, organizing, and maintaining data in a structured and secure manner to ensure its reliability, accessibility, and usability. Activities and practices which are aiming to effectively manage overall the data will be really required, particularly to keep their life cycle, or when to reject the data. That's very important. See, I may keep getting data, maybe a thousand data in per second or per minute. Naturally, we have a limited resources to store. We need to discard this. Naturally, what is the policy of discarding? Like many times when we have CCTVs and then we keep capturing the images, so we have some sort of data bank, or we have some sort of battery backup, but we need to really replace the data. And often people say it can keep a data up to 30 days, and 31st day onward the data will be deleted. Naturally, we need to have algorithm, we need to have some policies, and those policies need to be recorded. If policies are not recorded, then it will cause a violation of the rules, and that will be cause an ethical issue in this case. So let me start with the data collection, which already we have mentioned. However, here I want to give more emphasis on relevant information. We keep getting many data, but which information is relevant to us? Are we able to utilize appropriate sensors? are we able to find out the appropriate things. So that's important. Now this gathering data is we are saying internal database. It can be external sources also, but in these days we are focusing only on the sensors and IoT devices. As I say, from industry point of view, internal resources or internal database may have some important information, and external sources maybe in initially yes, but not a subsequent operation, because we are going for the continuous improvement on that. However, what is to be done? You say we need to ensure the collected data are accurate, efficient, and secure. It's very difficult to say data are accurate. Actually, we need to have some sort of algorithms. We need to have some sort of criteria, and even efficiency and security. Of course, we will be covering the security in the next few slides. However, we say clearly that this integrated data, collected data, should be kept in repository or centralized repository. So there the really data analysis is very important. Often we do some sort of optimization and we use a word established data pipelines. That what is a data pipeline? It processes and it keeps some operation of the extraction, transfer, and loading the data to whatever the destination we define it as. So this is the complete data pipeline. And what is the meaning of the transformation? We say after extraction of the data, often we need to clean it, maybe filter out, and we say irrelevant data should be removed completely. Often we need to require a normalization of those data, and if you are getting from different resources similar kind of data, then we need to make it much more useful by aggregating, connecting with each other, and then overall results need to be stored. Now in this case, I will just give one example. We picked up this data from website and the picture from website. What they are saying, SpaceX collects a vast amount of data during the rocket launches. Now, data are coming from telemetry data, video feeds, and sensor readings. So they are coming from three different sources. This data which is collected on board sensors also, ground station, and tracking system to monitor the performance and safety of the rocket during flight. So we have a diverse data, and then we need to have algorithm so that we different data connected with each other, and then they are giving some sort of conversion, a similar kind of indication. If there is a one failure, at least that should be notified. Two other system are still giving the readings. So there will be some sort of the algorithms to track this data and process those data appropriately. Coming to the data storage and organization, we already know about the hard disk drives. Now we say that instead of hard disk drive, when we want to go for the faster access, naturally we need to go to solid state drives. And most of the academic institution we use only this hard disk drive or solid state drive. However, in these days, the students have started using the cloud storage space, where the third party is providing the storage space. There are number of third parties which are providing the cloud storage space. Another one is a network attached storage. This is required whenever we have a multi client and they want to see what is really happening, or even our own system we have a storage area network. Particularly it is all the things are done on a centralized storage management, and we get some sort of 1 terabyte space and you can utilize that. So these are the different the data storage purposes. As I say, SDD and SDD are common to the most of academic institutions. People have been utilizing it. Now, what is really to be taken care? We say mostly implement encryption, access control, and authentication mechanism. So, if there is a authentication mechanism ready, then only the data security can be kept. Otherwise there will be problem. Like even we want to check email our own system or institution, naturally they are providing some sort of authentication mechanism other person cannot see. So similarly, for when we are going for the institute measurement, data collection storage has to be done with some sort of authentication, otherwise there will be problem. Or sometimes we say that we are transferring data, that the data encryption is also very important. These are also we keep getting when we are using the laptops and all. We say regularly backup data to prevent the loss from hardware failure, disaster, or malicious activities. So we need to have that kind of regular phenomena whatever we are doing with the laptops, our own system. Same thing when we applying to the data enabled engineering, that is very much required. Sometimes we say that they should not occupy the more space, so we require compression, deduplication to reduce it. That happens mostly in our mobile phones in these days. We get a notification there are 3 files which are duplicating, maybe they are similar files, so we need to delete that. And as far as possible, try to eliminate the redundant data. There's no point to keep getting data and retaining those data. We need to delete those. And one more thing comes in these days, because earlier we were using the SDDs and SGD. Now people say that because we do not know exactly how much space is really required, quite possible for first 6 months we require only access space, and then if the system works in a proper manner, we require after next 6 months another access space, so it will be 2x. So naturally it should be scalable, and that's why the many times now in this comes the NAS and SANS is happening, or NAS and SAN is really getting more and more popular in these days. Often we want to organize the data into the appropriate structure, and we want to do a categorization, so that efficient retrieval, analysis and management can happen. I can cite example of the Uber. You can see, and then in this case, so particularly Uber organizes the ride sharing data into categories. What are the categories? Trip details, driver information, and payment transactions. So they are dividing it. So this kind of labeling is very important, and the categorization is very, very important. Similarly, now Netflix, they are famous for the video streaming. They utilize cloud based data, and then they take a service of the Amazon Web Services and Google Cloud Platform. So these data warehouses are designed to scale dynamically, to particularly thinking from what is the traffic overall, how many users will come. Maybe user may double, may triple, and maybe increase 10 times. So that's why they don't want to go with a fixed database, or maybe say the constraint database. It can be continuously increase or decrease, so it will be done not dynamically to accommodate the growing volume on the data or reduce volume on the data, depends on that. So this is what we have picked up from their websites, this kind of information, and it's because this is very common, that's why I'm trying to provide this kind of examples, so that better and better understanding can be achieved. Now coming to the main point, the data quality assurance, we say it is very much required. What are the two major things is the validation and standardization. Whatever we are getting from literature need to be validated, need to be standardized to identify and correct errors. If the something is not getting standardized, something is wrong, or there is some sort of validation issues, naturally those things in those data need to be rejected. And then if we are getting in situ, or we are getting from our sensors, naturally we need to change the algorithm, we need to provide better results to that. So say to enhance the consistency and comparability, data standardization involves establishing consistent formats, which are very much important, units and definition of the data element across the different sources, because we are getting from a different, even in situ we are getting from 3 different sensors or 5 different sensors. That also the data standardization is very much required. So finally, it will try to analyze in easier manner. As I mentioned, the data validation involves a verification of data against the predefined rules. Now here it can also constrain to some extent innovation, but this is very much required. Otherwise, we'll be getting many results, and then we may not be able to evaluate. So if there are predefined rules, we should use, but we keep checking whether rules can be changed subsequently. So I'm just saying that to validate something, we required rules, we required constraint, we required reference data to compare, but we keep changing, we keep looking at those data. If our system or our research is slightly different, we should justify, we can redefine the rules, we can redefine the constraint, we can redefine the reference data, but we need to have this as a checklist, so that we are able to ensure that whatever we are getting the data, quality of the data is really good. So data quality assurance is important. And then we say that when we are implementing the robust data quality assurance practices, reliability and trustworthiness of the data set increases, which are very much required whenever we are doing it. Now let's take example, and I'm again picking up from a website. Airbnb employs a data quality checks to ensure the accuracy of the property listing. So somebody is giving the wrong information. Naturally, we need to have some sort of automated algorithm which can detect or and flag the suspicious listing, because in these days there are a lot of cyber attacks. So there's a need to really keep important algorithm or automated algorithm which can really flag this kind of suspicious listing. And those are very important for us to then, provide, particularly detect the incomplete information or misleading photographs, so that overall people have a more trust, users are able to get benefit. So most of the websites are doing it, and it may not be directly connected to us, but we really require that data quality assurance. So that's why I'm picking up this example, so that it's easy to understand. One more important thing is the data governance. We say that actually we need to be very careful about the data policies. So what we say, define roles and responsibilities, establishing the data supervision. Naturally, whoever is maybe we have a team, 2 3 people need to have a supervising, need to supervise the data which are procuring from the data sensor or from the sensors also, and enforcing the data management policies. This is very important. The government have also declared the policies. If we want to do research in our lab, we can also make some sort of policies, so nobody can fiddle with that. So this is important. We say that data management policies to maintain data integrity and accountability. And if we are assigning some supervisory duty to the to few people, naturally if anything goes wrong, they will be accountable. If there is some sort of a data manager, and if he or she is able to supervise all the data, if anything goes wrong, naturally he or she will be accountable. If that's a situation, that will be easier for us to go with the data governance. We say that in this case we can also keep some sort of masking so that people do not see it, those data, or maybe some sort of data which are very private and people should not share, people should not see those data, or confidential requirements. This is the word we are using, the word GDPR, which is basically a General Data Protection Regulation, which has been framed by the European Unions. What this GDPR says, that data governance strengths to protect the privacy and rights of European Union citizens' personal data. Now here we keep getting some sort of phone calls from here and there, but whenever we are giving any data, that privacy has to be maintained. There need to be a rules and regulation, and European Union is really providing that kind of rules and regulation. Similar, maybe in India or maybe some other countries also will keep coming this kind of things, because breaching that this kind of data policies will be very bad. However, for our lab purpose, our experimental purpose, we also need to have some policies, so that when we are doing some sort of research, it is really not deviating, or some sort of data freezing, or maybe sharing is not happening. Because we do many times on a very defense related projects, naturally we need to maintain the data privacy importantly. It should not happen that those data are getting leaked, because then it will be major issues. So that's why we say data governance is very important. This is kind of the checklist. When we are doing anything or we are framing anything, then really naturally this point need to be kept in the mind. Coming to the data integration, there are a number of applications available. We say data integration tools are available. APIs is now one of the very common term. We say the application programming interfaces. ETL is another common term. We say extract, transform, and load. And one more point, it comes at data synchronization, to the integrate the data and ensure the consistency and coherence across the system. This is very important for us to keep in mind. Now, as I mentioned, the data synchronization, even when we are doing a work in a lab, we have a key phaser, we have some sort of accelerometer, we need to synchronize data so that we are able to get a good results. So that's why we say the data synchronization between different systems to ensure the information is up to date and consistent across all integrated sources is very much required in our case. With increasing demand for the real-time analytics and insight, data integration process are evolving. Now, this is another point. Newer and newer algorithms keep coming, and then we need to really keep in mind. However, whatever we do for travelological purpose, time synchronization is required. we need to implement those things. And then question comes, if there are newer and newer sensor, naturally we need to keep in mind what is the frequency, what is the really in the procurement data receiving time. So that's why the synchronization is very much required. So they say we can react quickly to changing condition of particularly for typo interface, and so that informed decisions have been made appropriately. So these are the again data integration, and then synchronization is the main thing. And if we have a two three different sensors, synchronizing those data output is very much important. Now here I'm giving example of the healthcare. You say that the IBM and the health integrates the data from electronic health record, medical devices, and genomic database to support the customization or say personalization medicine and healthcare analytics. So they keep data and then they are able to provide the personalized medicine and healthcare analytics. So suppose we have some sort of problem with some medicines or some sort of allergy, then those things also can be incorporated. Similarly, when we are using the different kind of sensors, and then one sensor is not giving very good results, or we really require to go ahead with the recalibration, that also can be detected utilizing this kind of services. So data integration is very much important. In this case, particularly IBM Health Point, you say integrated approach enables healthcare provider to analyze patient data comprehensively and deliver more precise treatment. So same thing happens with our sensors also. If the sensor doesn't have accuracy, or the sensor is not able to receive the signal so fast, or maybe they can have some sort of a upper limit of 10 kilohertz frequency, those things needs to be assigned or aligned appropriately, so overall data integration can happen in appropriate manner. Last one in this case is the data lifecycle maintenance. We say that we should not, we need to start discarding the data also. It's not a once we have got the data, it will be always in our system. So we say the process of managing data from initial acquisition through its a final deletion. So we need to think about the final deletion also. Ensure the data remains relevant, accurate, and cost effective. Reason being, whatever the data the storage capacity we have or we are hiring from some third party, if we keep bombarding with the data, that will be filled and it will turn out to be that we need to pay a little bit more on that, so that will not remain a cost effective. So we need to start deleting. However, we need to frame the policies when the data should be deleted. And we say the defined data retention policy, managing data backup and archives, and disposing of obsolete data to overall organize in a well-defined manner. And then we say data archival involves a moving inactive or historical data from primary storage to secondary storage. If we have this primary storage, secondary storage, we can do it. Otherwise, we need to continuously check it. And then if whatever information which is not relevant, we can delete. But again, we need to keep in mind that should be defined well in policy. We cannot delete selectively some information, it will create again another ethical issues. So we should not we need to define what are the data retention policies, and we need to go ahead with those policies. So what we say, data disposal involves a permanently removing the data from a storage system, ensuring that it cannot be recovered and accessed. Reason being, many times we have a data, other parties can utilize and or maybe say misuse those things. So naturally, we need to think securely deleting or disposing of in compliance with the data retention policy. As I mentioned, we need to maintain, we need to frame the policies. And then most of the websites or big industries, they have a data retention policies, and then they also keep a privacy regulation, because when we are deleting something and somebody recovers those data, then there is a privacy regulation comes into picture, and it need to be really meeting the legal requirement. I'll just give example of the Facebook, which is available on this website. We say Facebook implements a data lifestyle management policies to manage the life cycle of a user generated contents on its platform. Content moderation algorithm automatically identifies and removes prohibited contents, while user data is archived and deleted according to Facebook data retention policies. So they also have addition that they identify and remove any content which have been prohibited. by the company. So this is very important. Now this is very much required when we are going with our own system, and then we know there is a possibility of virus attack or some sort of by mistake is deleting some file. That should be prevented. Many times when we do research and then we have 10 research students and one person doesn't have a complete knowledge and he deletes some file, that's also possible. So we need to prevent that, and we need to have some sort of a authorization, and after that we need to have also backup. When the file deleted, we need to have somewhere backup so that we have appropriate measures. And then even when we are deleting it, we need to show that it is meeting the data retention policies and the deleting policies also. Otherwise the data management will be little more difficult. Now, after this, we are coming to the ethics. We say ethics in a data enabled engineering. It related to the privacy concern, bias, transparency, security. To some extent, we have covered in the previous slide, but there are a few other things with like impact on society, and we should think about a responsible innovation. So these are the important aspects. We say data enabled engineering brings about various ethical challenges, mainly collection. How do we collect? How do you use and manage the data? And then what is the meaning of ethics? It can be defined in different manner, but we say that here ethics is what is the difference between the right and wrong, and we avoid the wrong things. We should do only the right. And we say addressing these challenges requires transparent collaboration between the engineers who are engaged, data scientists, ethic experts, and policy makers. So whatever we need to go ahead with a collaborative environment, and then whatever we want to do, if it is done in a collaborative manner, it will be very important. I'll just give you the two very quick examples which are very common, particularly for the academic research publication. We see the two most common frauds which happen in academic research publication is cherry picking and fabrication. What is the meaning of cherry picking? We say practice of selectively choosing data support that a particular viewpoint or hypothesis or conclusion while ignoring or dismissing those data which are contradicting it. So we made a hypothesis, yeah, this sensor is good, but there are number of data which are contradicting it, and selectively we pick up only those data which are really supporting our hypothesis the sensor is good and can be utilized. So it involves presenting a kind of the bias or incomplete picture. Now if you have done experiment and then you got a 10 data and finally you are publishing only 3 data, you are rejecting 7, that there is a problem because we are giving incomplete picture, we are hiding signs, we are giving only our one view which is not correct for the society. And it has been observed that most of the publication they do this, which is wrong and it should be avoided. Another one is a fabrication. We are not done experiment and we are getting the results, or we know that the results should be around 2 and we got around 7, and it's oh, to leave it and we will fabricate it, we'll make it 2. So that is also not correct. What will happen, we are not getting reliable database, and then for the growth of the society we really require reliable data so that overall machine learning can be utilized and we continuously improve the systems. In particularly this kind of frauds, continuously improvement of system is very difficult. Believing each other will be very difficult. So we need to have some sort of policy ethics. Of course it has been mentioned in number of times ethics, but people have to have some sort of firm rules, then only those things will come. So that's why I'm trying to say ethics in data enabled engineering. So we need to have some sort of framework or some sort of checklist at the different levels, offering the general principle and a specific insight, addressing those ethical dilemmas. Now as I mentioned, we have a number of articles where people say you honor the dignity of others, upholding integrity, striving for the fair outcomes. They are valuable, there's no doubt. But we don't have a quantification, we don't have a good checklist, we don't have a criteria what will happen if somebody is doing something wrong on this. So we need to have some sort of a checklist, and then if somebody violates those rules, what are the punishments? So what we see, converting these principles into tangible outcomes requires the tools to add individual in navigating ethical dilemma or kind of navigating this checklist so that we can go ahead with in proper manner. However, in my view, we need to proactively integrate this ethical consideration into design and deployment itself. At the beginning itself, when we need to integrate, then it will be very good for us. And with this, if some organizations are able to bring this ethical the points or consideration itself in the data enabled engineering technologies, naturally organization can promote, they will be able to do a good responsible innovation, and then they can mitigate any harm which is going to happen to the society. So what is the overall goal? To ensure an overall ethical and beneficial impact of the approach. So this is very very important to keep in our mind. If you are not able to do, then there will be problems. So what are the general ethical issues? We say accuracy, bias, and then fairness. And of course accuracy is, we know very well that if we do not provide accurate results, identification of failure will be very difficult. So for technical purpose, from engineering point of view, accuracy is very very important. But what are the major problem? What is the ethical issues? Accurate data tend to be very costly. You need to do number of time experiments. It becomes very costly. So that's why the many times people think about ethical lesser of, and they don't follow the ethics, and that's why they raise ethical concern about those things. Now this is another good point which is need to be highlighted, is the bias. We already have planned something, what kind of results we want, and then we make everything according to that. That's why we say the planned distortion in decision making that results in injustice outcomes. Often it is done. The origin of the bias very maybe from the data related, even whatever the samples we are selecting is something like, we have a coal data, the coal has come through the test it, we selectively choose a sample which we know very well it is a very good out of instead of the going for the random selection. So sample selection itself is getting biased, because we know maybe we got 100 pieces and we know the 5 pieces are good, 95 pieces are not good, and then we will select only 5. That is a biased decision. Another one is the data collection. As I mentioned, that we get a number of data and we report only few which are going ahead with our planned outcome. Another one is the problems related to the algorithm. That means already we have given some sort of indication in algorithm what results are required. It's something like you get a very long code and you say that okay, I'll write algorithm, what is the finally outcome should come, and you print only that algorithm. Or maybe it's a writing statement that the final thing is this one. That is also the biased decision which is wrong. And then another one is the last one is a human making decision. Now in these days taking interview, people find a lot of human related problem decision making. That's why the many times interviews are getting now automated, it done by the automatic machine, by AI, so that we are able to say show clearly that it is, there's no human bias on that. So in this case what we see, all can contribute to injustice outcome and sustain prevailing inequality. Many people are not getting the equality, and that's a major issue. I'll cite one example which was published in the Science. We say in 2020 an investigation by ProPublica revealed racial bias in healthcare algorithm used to predict the patient risk level. Algorithm was found to systematically assign lower risk scores to black patient compared to white patient. That means whatever the medicine you take, whatever treatment you take, low risk will come for the black patient compared to the white patient. And this was diagnosed and then published in Science in 2020. Now, actually, another one is a fairness. We often say this product is useful in this manner, but we need to also say what are the negative points. So we need to provide all cons and pros, whatever the positive outcomes and what are the negative outcomes. If you are not able to provide a fair deal of the weakness and strength both, then there is some sort of ethical issues on this. So this is very important. Another one is a safety. We say the safety is very crucial, safety of the data, and sometimes it causes the more failure, or particularly when we are talking about how to process all the data, how to make a data pipeline in a proper manner. So in that situation, security, reliability and robustness all are required. What is the reliability? We should have a consistent performance. It should not happen one time one results, another time another results. Robustness, it should be right whatever the unpredictable situation, which is what we are seeing that now AI is going to provide that kind of a results to us. Finally comes the security. We say many times we have a sensitive engineering data and it becomes vulnerable to breach, and there are some sort of cyber attack and they are able to access those data, then there will be major issue. And then there are some points that some intentionally they are trying to poison the running data, and actually we know that it will not give a very reliable output, or sometimes some sort of algorithm change, so the model get inverted results, wrong results. And then some sort of adversarial interference attacks also. So famous example in this case is 2021 was a Colonial Pipeline cyber attack. What happened, they disrupted the fuel supply in the US east coast, and then that time it came into the picture the cyber security vulnerability of the critical infrastructure systems. So need to keep in mind, we are trying to do automation of each and everything, but somebody who has a good knowledge, or they can really make it the overall system vulnerable to the cyber attack. So we need to keep that in mind. So safety is very important, safety of the personal data as well as the system. It should not get some sort of explosion because of that. In this case it has been identified a weakness, and then we also kept in mind that now all industrial control system they should provide this kind of security. Reason being it have an impact on the public safety also, on national security also. So however, this complete detail has been provided on this website which I'm showing in this slide. We have issues related to privacy. We say very clearly many times we are visiting the number of websites and they keep capturing our data. They do AI to figure out what we like and what we dislike. They, in moreover, many times they have video cameras on and they are able to capture the pictures. So those things are very very important, and particularly more problematic for the personal use. May not be directly related to the tribology, but many times when we are taking some decision, and then if it is any times violating this privacy rule, that also keep in mind. So we say, let's take example of Google faced criticism in 2021, where third party cookies to track the users browsing behavior across a website for a targeted advertisement. They wanted to do advertisement, and we know very well this is a very common even in these days. Of course, when Google announced the plan of the phasing out third-party cookies on its Chrome browser by 2023, and this is also detail being given in this case. So we are getting inclined to the data more and more. We want to apply data everywhere, but there are many problems also. And when we are getting acquainted, we need to also think from an ethics point of view. Are they really ethical? And then wherever we are able to make a policy, wherever we are able to bring our knowledge in a betterment for the society, we should do that. One is the transparency. Many times we get data, what is the intention of those data, that also should be informed. And if we are taking data from various resources, that also need to be accounted properly. So that's why we say transparency in machine learning involves providing user and stakeholders with the necessary information to make informed decision. Here we need to do both. What is the final product which is going to come and how it will be processed also. Both are necessary information to be given to the user also, or person who is a stakeholder. Additionally, we say that transparency need to come how this data will be interpreted. We say something, or maybe our sensor is giving something, interpretation of those data in appropriate manner should be listed down properly, so that from one user to other user the things are not changing. So interpretability is also important. Explainability is also is important. Many times people say, oh, this is we have got from ANN or deep neural network. That is a black box. We need to explain what is the interpretation of that. Whatever we are getting output, what is the interpretation of that. We cannot say that the algorithm is giving and we need to rely on that. That's not correct. So we really require transparency and understanding also. Inference is also important. Let's take example of the 2018 and the Facebook faced major issues, particularly from Cambridge Analytica scandal. You see there were personal data of the million other Facebook users were harvested without their consent for the politically. profiling. So if we are taking our data, personal data, and utilizing for some other purpose, that is a violation of the rules, violation of the ethics. So that also need to be accounted. More details have been provided on this website about this. Again, this is not directly related to our topology course, but this is very important in future. Maybe if something comes, we need to keep in mind whatever we do, we need to list down and that keep in a safe manner, so whenever it is really required, it can be utilized in appropriate manner. Last one is, in this case, is accountability. Even we are trying to make a number of autonomous vehicles or autonomous devices, but whatever wrong goes wrong, the humans are responsible, and accountability has to be fixed. If machine goes in a wrong direction, if instead of reducing the friction suddenly increases, and instead of reducing wear increases, person who's, even though we can do everything with the data or data enable engineering or data driven approaches, but we really need to make supervisor person who is really responsible for that. Otherwise there will be more issues. So that's why we're saying the establishing proper processes to consider the risk, documenting policy and procedure need to be accounted, so that finally whichever the parties are affected, they can be given the right compensation. Even if we go for the insurance, these are the very important aspects. So accountability is very much important. For responsibility to be fixed for the human is very important, because what final we say, whatever we do, humans are responsible for that, because they are going to interpret the machine learning algorithm, they are giving the data, they are picking up the data. So those things are very important for us. Now is a not directly related, but there's a some sort of legal dispute which happened in 2018 between Oracle and the Google. If you have a detail everything in documents, then these legal cases can be easily dealt. If you don't have everything documented appropriately, then the problem comes. So what was the legal dispute between the Oracle and Google was that the use of Java programming language in a Google's Android operating system. So question comes, what is the really IPR and who has IPR, and whether utilizing a similar kind of IPR in other stream can it be useful? Or whatever I mentioned is mentioned mainly from whatever we do, we need to keep everything appropriately and document appropriately, and then fix a person who is really responsible for that. Accountability need to be fixed in this case. Last, as I say, that the society, because many times society gets impacted with that. Now in this case particularly, we say we are talking about ML, but ML is going to be energy intensive, and an energy itself is a criteria for sustainability. If we are taking more and more energy by utilizing algorithm, we are consuming more and more energy, finally it will be an issue related to sustainability also. So we need to think about, as we initially mentioned, we need to mention about fairness. We need to show what are the positive things, what are the negative things, and how it will affect the environment, how it will affect the society also needs to be addressed appropriately. And if anything which is harmful to the society, we need to avoid it, because we want innovation which is useful for the society. Innovation cannot be termed as innovation if it is bad for the society or environment. So that's why the more clean thing has to come, and finally it need to be weighted against environment impact and sustainability. I'll just give one example. In 2020, Amazon faced criticism of facial recognition technology. They found some sort of a racial bias and inaccuracy in identifying the people of the color. So if that is affecting the society, our ML algorithm whatever we make, and it is incorrect to some extent to identify the person's color, or maybe the inaccuracy is being there, then it is affecting the society. So whatever we do, it should bring equality. It should not be a kind of some sort of a biasness or some sort of inclination towards one society or other society. So these are the issues, and then we really require to incorporate in our data management. Whatever we do is really important. So final last slide, I say what is a trustworthy data enabled engineering system. We say encourage meaningful participation, foster the collaboration among the different disciplines within organization to broaden the product vision. which is in long term very much required. In short term it may be little burdensome, but in long term it is very very important for us. Practice data minimization. We should not think about we need to get many data which are very relevant to us only. We collect those data. So practice data minimization during the collection. Collect only necessary data from user to ensure the privacy compliance. It should not happen we are trying to take in more data, assuming later we will be using, and then we are not worried about those data, we are discarding, and somebody else is using those data in a wrong way. So that also we need to keep in mind. Clearly communicate intended use of the collected data, why we are collecting those data, and if it is not being utilized we need to dispose of in proper manner. Ensure accessibility, that whatever we may use, people should have a completeness. Of course we are also mentioning very clearly we should provide a authentication. People who are authentic to use that, then only they will be utilized. However, we need to keep in mind there should not be any demographic differences. If there is a demographic point, or maybe some sort of inequality comes, we need to remove that. That's important. Regular impact assessment should be done. Whatever the technology we make, we should have a fairness, we need to have transparency, and we have robustness. In addition, there should be audit of the technologies, so that there are a number of agencies who do this audit of the technology, and maybe even the energy audit and all. So they utilize some sort of fairness matrix, bias measurement, robustness matrix into design and development phases, and we need to keep those things in our mind so that overall results are profitable for the society. So whatever we do, it should turn out to be useful to society, useful to the user. The ML should be utilized for the betterment. It should not be utilized for the individual purpose. It should be for the betterment of society. With this, I say thank you for attending this lecture. Thank you.